Hello, this is Rick, and today we're going to be working on a few examples of solving exponential and logarithmic equations. For those of you interested in following along at home, today I am wearing my summer aspen slippers. Probably not the most appropriate thing to have on at the office, but as my radio and TV professor once told me, it's good to feel comfortable when you're recording. So I'm comfortable. So what we're going to work on today is the equation, solving the equation 5 to the x plus 2 equals 4 to the 1 minus x. Okay? Now remember, as we said, one of the things that logarithms are powerful at doing is turning exponents, powers into multiplication, and turning multiplication into addition. So that's what we're going to do, and I'm going to use natural logs. I could use common logs, but natural logs are the thing we get used to using in mathematics. It's the one that's most commonly used, and since I've been doing this for 15, 18 years now, it's the most natural to me. So natural logs, get it? It's a joke. Okay, so I'm going to take the natural log of both sides. I will get the natural log of 5 to the x plus 2 is equal to the natural log of 4 to the 1 minus x. Okay. Now remembering my properties of logarithms, if I have the log of something to a power, okay, I can take that power and I can move him out front. So I'm going to have x plus 2, that whole power, times the natural log of 5 is equal to 1 minus x times the natural log of 4. Now, this is becoming just like a standard equation solving problem from the review unit. So I've got x trapped inside of parentheses, so really what I need to do now is expand the parentheses, get the x's out, gather them up, and then continue on from there. So that's what we're going to do. So I'll have x times the natural log of 5 plus 2 times the natural log of 5 equals the natural log of 4 minus x times the natural log of 4. And now what I'm going to do is I'm going to take my x's, move them over to the left. I'm going to take my constants, move them to the right. So I will end up with x times the natural log of 5 plus x times the natural log of 4 is equal to the natural log of 4 minus 2 times the natural log of 5. Now I'm going to factor out my x. So I will get x times the natural log of 5 plus the natural log of 4 is still equal to natural log of 4 minus 2 times the natural log of 5. Now, some of you may be wondering, since I started getting these constants, like the natural log of 4 or the natural log of 5, why I'm not just putting those into my calculator and getting some decimal values for those. Well, the reason is if I make my substitutions too soon, if I get a decimal approximation, and that's all you're going to get. These are going to be irrational, ugly decimals. They're not going to be pretty exact numbers. So if I do it too early, then I introduce error by my round off too early in the problem. And that round off will propagate itself through while I'm doing other calculations. So if I'm off by a little bit and then I multiply those numbers or divide those numbers, it's just going to magnify that error all the way through the problem. So I'm going to wait till the very end to do any kind of substitution, and then I'm going to do it all at once that way. I'll put it all in my calculator at once and get a value, and that way I don't have that error following me through all the way. It may not seem like a big deal, rounding something to 5 or 6 decimals. Okay, so maybe it throws your answer off to the nearest thousandth. Well, the error adding up does make a difference. If you don't believe me, check with the families of the soldiers who died in the first Gulf War when a Scud missile hit their barracks in Beirut. The reason that missile made it through is because of error that was adding up and propagating through the clock of the Patriot missile system. They weren't able to reset the clocks as often as was required because they had to be on duty all the time. And since that error multiplied, when it came time to figure the time to send the Patriot up to intercept the Scud, the air had moved its way through the system, and as a result it completely missed the Scud, and the Scud landed on the barracks and killed those folks. So air moving its way through the problem can result in death. So let's just avoid that if we can, shall we? Okay, so here's what I'm going to do. I'm going to take x is equal to the natural log of 4 minus 2 times the log of 5, all divided by the log of 5 plus the log of 4. Now, this is going to take a few steps on the screen, but once you get used to the properties of logarithms, it won't take you much time at all. What I'm looking at is, okay, I've got 4 different logarithms here I need to be messing with. But if I remember my properties of logarithms, I know that subtraction of logarithms is division of the numbers in the logarithm. I know that a constant times a log is just that number to this power. I know addition is multiplication within the log. So I'm going to follow that idea and say, okay, I'm going to have the log of 4 minus the log of 25, because that's 5 squared. And down below, I'm going to go ahead and say log of 5 plus log of 4 is the log of 5 times 4, which is just the log of 20. And then I'm going to make one more here, and I'm going to say this is the log of 4 divided by 25 over the log of 20. And now I've just got one easy fraction, 2 easy logarithms that I can put into my calculator and evaluate my answer. And when I do that, I come up with, what did this come out to be? Negative 0.611, if I can read my handwriting. I believe it's 931, but check it yourselves at home on your calculator. It's going to be something very close to this. And again, I should change this to this is an approximation, because remember, I'm not going to be able to get exact values on these. It's going to be an approximation. So that's first example. Be sure and check out the other examples you see on Patrick JMT and Math is Power for You. Those other videos I have posted from YouTube. Those have really good suggestions and walkthrough on examples as well. So with that, goodbye until I see you on the next example.